So, how can you do this problem in 30 seconds or less? For each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? So these two equations are equivalent to each other. So x is equal to 7 halves minus 3y over 2. And the answer is B. How was I able to do this problem so fast? So first things first, we need to identify, we need to detect that these two equations are in fact identical to each other. So how can we do this? So if you take the first one, 2x plus 3y is equal to 7, and we multiply every single term by 5 on both sides, what we are going to get is this is 10x, this is 15y, and this is 35. So I'll just write it out. So 10x plus 15y is equal to 35, which is identical to the second equation. So therefore we know that this system of linear equations has infinite solutions. Question is how to describe the infinite solutions presented by this system of linear equations. So what I would do, I would take the first equation, 2x plus 3y is equal to 7, and I would solve for x first. Again, we need to kind of get lucky, so let's solve for x. So 2x is equal to 7 minus 3y, divide everything by 2, we're going to get x, which is equal to 7 over 2 minus 3y over 2. Now, from here on, if y is equal to r, then when we plug in r for y in here, then x is equal to 7 over 2 minus 3r over 2. Hence, the solution is going to be 7 half minus 3r over 2, comma, r, right? So that is the system, that's the solution for this infinite solutions, therefore, which is magically matching option B. Now, we got lucky. We got lucky by solving for x. What if you solved for y? So we got 2x plus 3y is equal to 7. So minus 2x, you get 3y is equal to 7 minus 2x. Divide everything by 3, and you get y is equal to 7 thirds minus 2x over 3. Now, in this case, if x is equal to r, then you plug in r in here, you get y equal to 7 thirds minus 2r over 3. Here's a problem. The solution, therefore, is r, comma, 7 thirds minus 2r over 3. And unfortunately, we don't see it anywhere. So c is kind of close, but unfortunately, it's a plus here, not a minus. So c will have to go. Now, d will be wrong, because we know this is r, but this is completely something else. So d is out. So it's between a and b. And a is this really weird answer. And it's typically difficult to get to that answer. So the best way to check whether A is correct or not is to plug it, say, into the first equation, because the second equation is the same thing. Just plug it into the first equation and see if it works. So what I'm trying to say is there's definitely some luck associated with have you solved for x or have you solved for y. Had you solved for y first, you would have to then solve for x as well, which will increase the length throughout which you are going to solve this problem. But in any case, the answer is B. That's it.